This is the GRE and IPSEC lab. Let's go to action item number 1. You're assigned the objective to connect to IPv6 networks, network A and network B, over an IPv4 network. Use an overlay protocol. Use the command show interface tunnel 0 and capture packets to check what protocols are transporting the traffic. So we have IPv6 networks here, and we are going to use a protocol in order to connect them through an IPv4 network. So we have an IPv4 network, and we're going to connect two IPv6 networks. So let's go to router 1, and the router 1 can reach router 3. Router 1 can reach router 3 and can also reach PC1. And router 3 can reach router 1 and it can reach PC2. So let's create a tunnel. Interface tunnel 0. Tunnel source gigabit to 0. And tunnel destination is the IP address that belongs to router 3. And the IPv6 enable, we're going to use IPv6 on the tunnel address. Okay, now let's do that on router 3, the opposite. Interface tunnel 0. Tunnel source gigabit to 0. Tunnel destination is the IP address of router 1, which is this. IPv6 enable, IPv6 address 2002.2.64. So let's do show interface tunnel 0. Notice that it is up. This is the source, this is the destination, and it is using GRE. So this command will tell you a lot of things, including what protocol is being used to transport traffic. Show interface tunnel, it is up. So we need to set up static routes. So both IPv6 networks can reach each other. So IPv6 route 2064 is reachable through the tunnel. Right. And on this side, IPv6 route in order to reach 2001.64, I have to go through the tunnel. So now PCs should be able to ping each other. 2001. Okay, great. Ping 2001. I'm going to do a trace to see what are the steps, hops. Okay, this is my default gateway, and then this is the tunnel. Okay, great. Now let's capture packets here. Let's capture, and let's fire up some pings. And notice that the traffic here is generic routing encapsulation, and it is carrying IPv6. This is the source and the destination. So we can use a packet capture, or we can use the command. I'm going to stop it. Show interface tunnel. Show interface tunnel will tell me that we're using GRE. Okay, so let's go to action item number 2. The IPv4 network is insecure. Add security using crypto maps. Validate with a pin and show crypto commands. Use the command show interface tunnel and capture packets. Okay, let's go into configure crypto maps. So let's go to router 1, and first of all we will need to configure phase 1. We're going to create policies. I'm going to create only one. Authentication, pre-shared key, encryption, this. You should not use this. This is only for the lab. The hash, MD5, and the group, Diffie-Hellman group. Number 1, you should not use MD5. You should not use this. You should not use the Diffie-Hellman group number 1. This is only for the lab. Now let's establish the authentication key. Crypto is a KMP key lab for everyone. And then let's configure as phase 2. Crypto IPSEC IPSEC transform set lab. I'm going to choose this and MD5. You shouldn't use this, and you should use MD5. Tunnel mode transport, and then we're going to create the crypto map lab 1 IPSEC is a KMP. I didn't create the access list. I forgot. I want to create it now. Match address lab set transform set lab and set peer. This is the remote IP address, which will be the router number 3. I'm going to create the access list extended lab. We're going to permit. This is the interesting traffic. The interesting traffic will be the traffic that will be generated by the GRE from the tunnel, that will come from host, localhost. This is my IP address. This is the tunnel source and tunnel destination IP address. Okay, now I have the crypto map in place. It is okay. Now I'm going to go to the WAN interface. Gigabit 10. It is the WAN, the wide area network interface. No, I think it is G20, and I will apply the crypto map lab. Okay. In order to troubleshoot it, show crypto is a KMP security association. Nothing. Maybe if I ping to create interesting traffic in order to set IPSEC off. Okay, this is cool because I have not configured IPSEC on the other side. So you should see QM idle here. QM idle is what you want. You don't want this. So let's go to router 3 and configure phase 1. Policy 1. This should match the policy on the other side. So my encryption should be this. My hash will be MD5. My authentication, reshare, and the group, the Diffie-Hellman group will be 1. This should be match the other side. Then the pre-share key will be lab for everybody. Then I have to configure phase 2. Transform set lab ESP des and ESP MD5 mode transport. I don't want to use tunnel mode, but transport mode here. And create a crypto map. The access list, IP access list, extended lab, permit, GRE, host. This is the source and destination for the tunnel. This is my IP address 23.3, and the other side is 12.1. Okay, now let's create a crypto map. Crypto map lab 1 IPSEC to CCNP, match address lab, set transform lab, and set peer the IP on the other side is, sorry, my microphone is falling down. It's this one. Okay, so my crypto map looks like this. Let's apply to the one interface, G20 crypto map lab. Now everything is in place. Let's issue show crypto is a KMP security session. Let's ping. Let's create traffic. Okay. Okay, this is what you want. This says that phase 1 is okay. Let's do show crypto IPSEC security association. You want this, you want active, and you want active. Remember, for phase 1, you only generate bidirectional security association, which is fine. This is a bidirectional security association. This is fine. With QM idle is fine. And with IPSEC phase 2, you create 2 security associations. The outbound security association is active, which is okay. The inbound security association is active, which means that it is okay. And some other information. The outgoing interface is to 0 with this crypto map tag. You have statistics. You have your SPI, inbound SPI, outbound SPI. So it is working now. Let's ping it. Okay, great. Trace. I am going through the tunnel. These are the IP addresses that belong to the tunnel. So everything is working great. Now let's see the capture of traffic. I'm going to send pings and see how the traffic is going. Okay. Now I can see only IPSEC traffic. This is IPSEC traffic. This is the ESP header encapsulating security payload. It is should be the protocol 51. It should be around here. Yeah, 50. I'm sorry, 50. Protocol 50, and this is protected traffic. It is being encrypted. So to answer the question here, what protocols in action item number 1, the protocol is GRE. Let's see. Let's issue the command. I'm going to stop this. Show interface tunnel 0. It tells me that it is using GRE. So internally, we're using GRE. So we're using here GRE over ESP IPSEC. So IPSEC is transporting the traffic, but internally GRE is working. So let's go to action item number 3. Improve the configuration using IPSEC profiles and validate doing the same. So we are going to move our configuration from crypto maps to IPSEC profiles. So let's go to use IPSEC profiles. So right, crypto IPSEC profile, lab profile, and we have to set transfer set lab. These transfer sets already exist. Now let's go to interface gigabit 20 and erase the crypto map. I'm not going to use crypto map now, and I'm going to go to the interface tunnel 0 and use tunnel protection IPSEC lab profile. Lab profile, okay. Lab profile, okay. Sorry. So now let's see how is the ISACM. Show crypto. I have one QM idle, which is funny. So I'm going to go here and give it to 0. I'm going to delete the crypto map on this side. So, okay, now the security decision is dead. And I'm going to create the IPSEC profile here. Crypto IPSEC profile, lab profile, set transfers, lab. The transfer set is already configured from the previous point. And let's go to the interface tunnel 0, tunnel protection IPSEC profile, lab profile. Okay, now we're using IPSEC profiles rather than crypto maps. So this is better. Let's see if okay, QM idle. This is great, and this is funny. We see two security association with profiles. Let's ping it. Okay. If I issue show interface tunnel, I am still using GRE and still using GRE. And let's see the capture. So I'm still using IPSEC with ESP. So to answer the question, what protocol is GRE over ESP? GRE over IPSEC. So let's go to action item number 4, enable BTI. So with BTI, we get rid of GRE. So I don't want to use GRE anymore, only a pure IPSEC solution. So let's go to, I'm going to stop the ping. Let's enable BTI, interface tunnel, and tunnel mode IPSEC IPv4, and I'm going to do that on the other side as well. So how can we tell that it is configured? If I issue show interface tunnel 0, notice here, I am not using GRE anymore. I am using IPSEC to transport the traffic. GRE is no longer used. But bad thing is it doesn't work because this feature only works with IPv4. It doesn't work with IPv6. So if I ping the other side of the tunnel, I will not reach it. This doesn't work with IPv6. So in order to make this work, I'm going to configure IPv4 on the tunnel just to notice that this works with IPv4 IP address. Notice that this is the current configuration. I'm going to delete this IPv6 address. I'm going to enable IPv4 because currently it doesn't work. So let's change this. It will break the lab because this feature doesn't work with IPv6. I will set up some new IP address like this, just for the tunnel to start working. No IPv6 address, IP address. So if I ping it the other side, it should be working now. I'm going to create a ping. It doesn't work for these PCs because IPv6 is broken now, but I'm going to ping the other side of the tunnel just to see the packets flowing. I can see the packets going from router 3 to router 1 using IPSEC. And the transport is IPSEC. So in this case, the answer here is what protocol is transporting the traffic? It is IPSEC only. But it won't work with IPv6 only, with IPv4. Okay, that's it.